Solve the triangle given angle A is 40 degrees, side A is 12 centimeters, side B is 14 centimeters. If two solutions exist, find both. Round your answers to 2 decimal places. So let's go ahead and draw our triangle. So we have angle A, which is 40 degrees, and we have side A is 12 centimeters, and side B is 14 centimeters. So the kind of triangle we have is a side-side angle, SSA. So when we have that, that's an ambiguous triangle. And so what we want to do is find the height of the triangle. We do that by using height equals B times sine of A. So 14 sine of 40 degrees. So we find that the height is about 9.00 centimeters. So 9.00 centimeters. So if we put this in order, our height is smaller than side A, and then side A is smaller than side B. So when that happens, we have 2 triangles. And so one thing that cannot change are our givens. So angle A is 40 degrees, that must be 40. Angle B stays the same, not angle B, sorry. Side B of 14 centimeters stays the same, and so does side A at 12 centimeters. So when the height is less than A, what happens is this 12 centimeters can swing to the inside to here, and that A would still be 12 centimeters, but now we have a B2, and then we have a C1 here, so C1 would be all of it, and then we would have a C2, which is right in here. So we would have the first triangle would be this triangle here, the black outline. The second triangle would be when the A swings in, and so we have this triangle, which is an obtuse triangle. So, and this only happens when you have the height is less than A and A is less than B. So let's solve for the B first, angle B, and so we'll solve for B sub 1. And so we're going to use sine of B over B equals sine of A over A. So sine of B equals B sine of A over A. B is 14 sine of 40 degrees divided by 12 centimeters. Okay. Then when you solve for angle B, so this is B sub 1, B sub 1 is approximately 48.58 degrees. So now there would be a B sub 2. B sub 2. Now to find that, really all you have to do is you take 180 minus 48.58 degrees. That's how you find the second angle. So B2, you take 180 degrees minus B1, and that gets you your second angle. So 180 minus 48.58 degrees gives us the second angle, 131.42 degrees. So B2 would be this angle right here, 131.42 degrees. Now, we'll go ahead and solve for the first triangle with our B sub 1 is 48.58. So let me label that here, 48.58 degrees. And so we'll want to solve for angle C. And to solve for angle C, we're going to take 180 degrees to solve for angle C minus the 40 degrees of angle A minus 48.58 degrees are B sub 1. So when you do that, our angle C1 is 91.42 degrees. So that is C sub 1. So that would be this entire angle right here. Now to solve for side C, then we do C over sine of C equals A over sine of A. So C equals A sine C over sine of A is 12 sine of 91.42 degrees over sine of 40 degrees. Plug it in a calculator. The side C sub 1 is 18.66 centimeters. So that is our first triangle. So this is C sub 1, this distance right here. So we have B2, angle B2 right here. So we'll have to find C2, the small triangle, or some small angle up in here. So to find that C2 is, we're taking 180 degrees minus angle A, 40 degrees, minus my B sub 2, 131.42 degrees. Okay, so that is our angle A, and this is B sub 2. So when you solve for that, C sub 2 is approximately 8.58 degrees. So that is the tiny angle here. And now we need to solve for C2. So C2 is this side of the triangle. So we're going to use the same ratio for the law of sines. C over sine of C equals A over sine of A. And this will solve for our side C2. C sub 2 equals A sine of C2 over sine of A. So A is 12 sine of 8.58 degrees over sine of 40 degrees. So when you plug that in a calculator, the side C sub 2 is approximately 2.79 centimeters. Okay, and then that is that small side here. So there are both triangles.